Well, this is going to be kind of a big picture thing here. You've got three different equations that we're working with today. And I'm going to give you the general equation of each one. So square roots involves, well, the basic equation y equals the square root of x. Call that the parent graph. The general graph that tells you all the other stuff that goes with it. There's an a value involved that does stuff similar to what the a value in front of a parabola does. And instead of parentheses, we have a square root. That's an x minus h. And then there's a plus k that follows. So h and k have an impact on this type of graph too. Absolute value, a out in front, x minus h, close the absolute value, plus k. And cubics, there's an a value out in front of that one too. And this one looks the most like a parabola, x minus h plus k with regular parentheses, except it's cubed instead. So I think I could bust through a big chunk of this just kind of all at once. This, when we go from here to here, it's shifted to the left 3 units. Okay, remember with each of these equations it's x minus h, and so we kind of picture this as going the opposite direction. Inside the parentheses, this goes the opposite of what it would appear. Plus 3 goes to the left. And what happens when x is less than negative 3? It's imaginary, non-real, and because you'd end up with a negative inside the radical. So basically the graph will stop, and we'll look at the graphs here in a little bit. Equation y equals x cubed has been shifted, since this is outside a set of parentheses. In fact, we could write this like this: x minus 0 cubed plus 7. It shows up a little bit more that it's the k value instead of the h. This is the h because it's inside, that's the k because it's outside. And since it's k and k is a plus, k goes the direction that that we would expect. And so that's 7 units, up 7 units. And then this one here, this was shifted to become that. So this is shifted to the right, and it shifted to the right 5 units. Okay. Important point that's located at x equals 5. That's the vertex. And the parabola, or the square root, doesn't have a vertex. It has a starting point. This one has a point of inflection, but this one actually has a vertex. So different things. When you look from here to here, when it talks about moving up, down, left, and right, I think it's just much easier. Identify the vertex, or identify there's a locator point basically. This is going to be a negative 3, negative 4, and it shifted to become what? 4 comma 5. 4 comma 5. So if I compare this thing to that, did it go up or down? Well, it went from a negative, and specifically the y value went from a negative 4 to a positive 5, so it went up. How many units? Well, from negative 4 to positive 5, it went up 9 units. And then left to right, it went from negative 3 on the x-axis to positive 4, so it went to the right. And from negative 3 to positive 4, it went to the right 7 units. Best thing you can do, identify the locator point of the h and k to be able to do that. Consider this graph from here to here. Well, don't forget there's a 0 involved here. 2 comma 0 is that locator, point of inflection on a cubic. Negative 7, negative 2. So up, down, left, right, from negative 2, or from 2 to negative 7 went down. From 0 to negative 2, it still went down, but it only went down 2 units. And then left to right, from 2 to negative 7, it went to the left. And from positive 2 to negative 7, it went to the left 9 units. Okay, so last thing here, and then we'll hit the stop button. No, that's a good spot as any.